In this video, we're going to do some basic examples of finding antiderivatives. So here we're asked to find the antiderivatives of f of x equals 5x to the fourth. Remember, the process of antidifferentiation is the exact opposite process of differentiation. To find the derivative of a function like this, a polynomial function, we would multiply the coefficient by the exponent and then decrease the exponent by 1. So to find the antiderivative of a polynomial function, we're going to increase the exponent by 1 and then divide by the new exponent. That gives us the expression 5x raised to the 4 plus 1 divided by the new exponent, which is 5. Now let's simplify. That gives us 5x to the fifth over 5, which when simplified gives us x to the fifth. But x to the fifth isn't the only antiderivative of 5x to the fourth. Remember, we have to represent all of the antiderivatives by adding a plus c at the end. And we can always check our antidifferentiation by differentiating the antiderivative. Think about it. What's the derivative of x to the fifth? Well, it's 5x to the fourth. So our antiderivative is correct. Let's find the antiderivative of f of x equals -2 over y cubed. Well, in the same way that if we were differentiating this function, we would move the y cubed from the denominator to the numerator and make the exponent a -3. We're going to do that same thing when we find the antiderivative. So moving the y cubed up into the numerator gives us -2y to the -3. To find the antiderivative, we add 1 to the exponent and divide by the new exponent. And then simplify. And that gives us y to the -2 power. Or if you prefer to change your negative exponent to a positive exponent, it would be 1 over y squared. But again, that's just one of the antiderivatives of our original function. To represent all of them, we have to add a plus c. In this example, we're asked to determine the indefinite integral and then check our answer by differentiating. And we have the indefinite integral of 4 times the square root of x minus 4 over the square root of x dx. The first thing we're going to do is rewrite our function so that we're not in square root form, but we're in exponent form. And then we're going to bring the square root of x in the denominator of the second term up into the numerator and make that exponent negative. So that'll give us 4x to the 1/2 minus 4x to the -1/2. Anti-differentiate by adding 1 to each exponent in each term and then dividing each term by the new exponent. So that'll give us 4x to the 1/2 plus 2/2 over 3/2 minus 4x to the -1/2 plus 2/2 over 1/2. It's important to note here that once we've taken the steps to anti-differentiate the integrand, the anti-differentiation sign or the integral sign disappears. It goes away because we've done what it has asked us to do. Simplifying gives us 4x to the 3/2 over 3/2 minus 4x to the 1/2 over 1/2. And simplifying further gives us 8/3 x to the 3/2 minus 8x to the 1/2 plus c. Now let's check our work by differentiating this antiderivative to see if we get the integrand that we started with. So let's differentiate 8/3 x to the 3/2 minus 8x to the 1/2 plus c. Differentiating and then simplifying gives us 4 times the square root of x minus 4 over the square root of x. So it checks. Let's determine the indefinite integral for 5x plus 3 quantity squared. Now for these types of problems, we're going to start by expanding the integrand. Expanding the quantity 5x plus 3 squared gives us 25x plus 30x plus 9. the antiderivative of which is 25x cubed over 3 plus 30x squared over 2 plus 9x. Simplifying and adding our plus c at the end gives us 25 thirds x cubed plus 15x squared plus 9x plus c. Now let's check our work by finding the derivative of the antiderivative. The derivative of the first term, 25 thirds x cubed, is 25x squared. The derivative of the second term is 30x. The derivative of the third term is 9. And the derivative of any constant is 0. So we get 25x squared plus 30x plus 9. And that expression written in factored form is 5x plus 3 squared. So it checks.